Hi everyone, thank you very much for joining us today for this webinar. We're going to be talking about preparing your tech for cloud turbulence. We are absolutely delighted to be doing this as part of the Leeds Digital Festival. Clearly, where the time's a bit different, we would be doing it with you there. As it is, we're doing this via webinar, and we will do our very best, and hopefully everything will proceed smoothly. We're going to very briefly introduce ourselves, do a little bit of housekeeping, and then we're going to crack on with the main topic. So very briefly, who are DMW Group? We are a specialist IT consultancy business. We deliver complex business critical IT transformation projects. We see ourselves as collaboratively accelerating modern changes for organisations. We've been around for 30 years. And our experience covers advisory, delivery, engineering and business transformation. In addition to that, we have really deep technical knowledge of cloud, data and digital, and that infuses everything that we do. There's a few badges on here just for interest, really. I'd say what's particularly important with regards to this festival is that we're also delighted that we are now working in Leeds as well, having opened there last February. In terms of the team who are talking to you today, there's myself. I'll very quickly introduce myself. So hi, I'm Marius Rubin. I am the Chief Technology Officer at DMW, and I look after our technology offering across those areas, so cloud, data and digital that you saw on the previous slide. And that covers our architecture practice and our engineering practice as well. I'm now going to hand over to Rob to introduce himself.
Yep, so I'm Rob. I look after DMW's Microsoft practice, looking after our O365 and Azure capabilities and needs for our customers.
And lastly, we have Wong, who has contributed to everything you're seeing today. So he is the absolute hidden star of this, and he is also going to be managing the Q&A. You've probably, I hope, seen some messages from him as well, and he'll be moderating that when we get to it later. A few bits of housekeeping, so please do be active with the Q&A feed. Post any questions you have there. Vong is going to be keeping a tireless eye on them and making sure that they're curated, and we will then look at answering some of those when we get to the end. You may also find that you have some of those questions answered immediately in real time through the presentation. You'll see there's a little picture here which just shows you where the button is for doing that. Please do also provide feedback. We'd love to hear how you found this, and if you do, you will potentially win £100 of Amazon vouchers, so there's lots of good reasons to do it. Sadly, I can't apply for that. And lastly, as with all things, we're all doing this from home, so apologies in advance if any of our home network setups cause any issues. Please do bear with us, and if you are seeing any problems, please do flag via the Q&A mechanism that you're having, that you think there's some technical issues on our end. Right, so enough of the housekeeping, and let's get back onto the topic, this topic of preparing your tech for cloud turbulence. And before we talk about what you might want to do or how you might want to do it, we're going to really just spend a bit of time thinking about why this topic is important, and consider a little bit why you might want to do it in the first place. And so for us, really, and I think what we see in most of the clients that we engage with is that cloud is really about becoming future ready as an organization. And this is something we've sort of had to think, and we work across a number of industries, in the public and private sectors. And we think a lot of what you see with moving to cloud can actually be boiled down to three really fundamental things. And one of them is moving faster, shorter time to market. In other words, getting new functionality, new behaviors out in front of your customers more quickly. And those can be, customers, commercial customers. A lot of the time, those can be customers internally as well. Another reason we see being very common is to provide more reliable services. In other words, things that are available more often, things that require less intervention from your IT teams to manage them. And lastly, and I think this is, one that is becoming increasingly recognised, and if it wasn't already, is really the fact that the likes of AWS, Microsoft and Google are themselves innovating at a tremendous pace. And if you want access to the latest tools and technologies and things to use to delight your customers, then you want access to that pace, and you get that through cloud. This topic of preparing and this topic of becoming future ready is still kind of active. So when I think nowadays there's often a lot of focuses either on completely new delivery in the cloud, or indeed simply trying to migrate there entirely, and actually with this sort of assumption that isn't the job nearly done. And actually I think what we see, and we continue to see with a lot of our the organizations we work with, is that moving is still really in progress. And so we've got a bit of survey information here, which I'll very quickly dwell on. So the Right to Scale State of the Cloud survey in 2019 said that 58% of organizations will be focused on moving more workloads to cloud. And I think the thing that's worth thinking about there is it's not saying they're going to be focused on moving everything to cloud. It's saying that they want to move more. So in other words, they're in this state of being on the journey already, and that for the majority of businesses and organizations, they're still in the process of doing it. And it's really difficult. And I think the next bit of information really brings that home. So it's still the case that as much as 75% of workloads are still not in the public cloud. So clearly there's a huge way to go. And that's why we think it's still a topic. And lastly, I think in amongst all this talk about migration, which we have admittedly focused on for 2 slides, there's this risk that migrating things and modernising things are seen as totally inseparable. In other words, that you can't do one without the other. And I think this quote from McKinsey captures it pretty well. So that companies tend to fall into the trap of confusing simply moving IT systems to the cloud with the transformational strategy needed to get the full value of the cloud. And I think that's really what we're talking about today. So, what is the answer? And for us, it's really all about front running. So we talked at a very high level about what the sort of future readiness effects are that you're looking to achieve. But actually, there's a load of other stuff that you can do that is independent of migration, that you can do during or before, that we think are really worth focusing on, and that we can see delivering, we see day to day delivering a huge amount of value. And the ones we're going to focus on, and in terms of the running order, as a health warning, we're going to get increasingly technical as we go through, is that there's really 3 kind of big components to that. So there's empowered ways of working, in other words, how you organize yourselves to do this. There's the technologies that enable you to delegate control and enable those ways of workings. And lastly, there's the kind of lower level architectural considerations for what systems look like when you do this. I'm now going to hand over to Rob to talk a bit more about that path.
Yes, so the first part of that is the cloud adoption path. And so this is about establishing a plan to allow you to adopt cloud. It encompasses more than just the technology implementation. We see some of the key blockers to cloud adoption and the success of it being the lack of understanding or buy-in from various parts of the organization. And that can be both IT and business, who end up either being left behind or feel that they end up stifling progress. So making sure that you engage with those people, provide a skills plan, is really important. Your plan also needs to include those users and how the business and its users are upskilled in that cloud journey. They need to be able to be or feel that they can derive value from its implementation, and feel engaged in the adoption journey. So that whole communication approach is really important. As well, it's critical that you allow for iteration throughout your adoption journey. It's not just about trying to follow a waterfall plan. You will discover things that you didn't expect, and so that iteration to potentially go back to that planning stage and reassess your readiness needs to be allowed for. And also you need to allow for innovation. Cloud technologies are moving at a phenomenal pace at the moment, and they release new features all the time, which can either optimize your implementation or deliver new benefits to your customers and users. And so you need to be ready to be able to adopt those. And then governance and management for us underpins the implementation. It provides a sense of structure and guardrails to support that adoption journey and providing a level of security. And to that, we want to talk a bit about a cloud-first culture. And this is thinking about what we need to do from an organizational structure perspective. And so the first is having agility in your governance structures. And we typically see 3 types of implementation. You have the free-for-all, where there's a limited amount of guardrails and there's limited insight as well as to the value that's getting delivered. And you can quickly see that costs can spiral out of control, and you start to see concerns around gaps in security, for example. You may also see that processes are either ad hoc or duplicated. The complete opposite to that is the top-down command and control approach, where you end up with too much governance and the ability to actually do any adoption is stifled. And the organization becomes slow to react to those changes, which is not going to help you meet your time to market requirements. The model that we see that works really well is the role of community of practices. And so this was a focus on domain guidance. It's community and inclusive driven. And the community learns and grows together. Personal interactions are really highly valued. But the community doesn't necessarily always work on the same projects. They don't move as a group. What you try to do is spread that community throughout the organization. And we'll talk a bit at the moment about multidiscipline teams. I guess the other key thing to think about is how you do line management in this community. What you start to see is line management being more focused on things like personal development than managing the day-to-day work tasks of those individuals. So coming on to what we see with the squad structure, when we generally work with clients, we firstly see that initially they're separated into applications and infrastructure teams. And the communications between those teams are very transactional. And they're typically quite monolithic teams as well. They're not separated into features or capabilities. They move as a whole unit, and that can be, again, quite slow. Moving towards some of the more mature implementations that we see is squads being structured around feature teams. And so you have feature teams that are set up to deliver new capability in the organization, and those features are very specific in their nature, underpinned by a core technology team or platform team that mature and grow the underlying infrastructure capabilities that the feature teams need to allow them to deliver. And finally, at the peak of maturity, we see that moving into an SRE or site reliability engineering setup, where it's formalized, or their engagement, sorry, is formalized and underpinned by KPIs, service level objectives. And the platform teams continue to provide that key enabling support to those SRE teams as well in terms of the underlying infrastructure. And so that leads us into, well, what are the different pathways into cloud? And the one that we really want to focus on today is how do you modernize where you are on premise with a view to moving into the cloud in the future or running a hybrid setup, and what are the benefits associated with that deployment model. And so I'm going to hand back to Marius now to talk in a bit more technical depth about that.
Great, thanks, Rob. So I mentioned things are going to get a bit more technical. So this is where that part starts. And what we're going to do is talk a little bit about really what the architecture side of things is, and then talk about a few more practical things that can be done to realize some of those benefits. So we're going to talk a bit about cloud native versus traditional architecture. And cloud native is a term that's been used quite a lot. And I think it's useful, but it's worth briefly contextualizing it in terms of really what we're trying to cover when we talk about these architectures and almost the complete scope of capabilities you see when you're delivering IT solutions. And so where we kind of start from is this idea of just quickly considering the kind of overall of a platform capability, and really how you can kind of talk about what you've got and what capabilities you need, both on-premise and in the cloud. And this angle of it being about on-premise and cloud is really, really important, and it'll become hopefully clear how important that is from a preparation perspective as well. So I'm certainly not going to go into every one of these boxes, but I think there's just a few things to call out that are interesting and worth thinking about. So if you look at the overall model, there's actually a load of things where you can look at this and go, there's nothing really preventing this model being absolutely valid for both an on-premise and a cloud environment. And what we're talking about here really is there's a hosting provider somewhere in the mix. In other words, it may be you, it may be a team, your own teams in a data center, it may be Amazon, or it may be Google. But fundamentally, someone's taking care of actually managing that. Then you've got these various layers which you can at kind of ever increasing levels of abstraction between the infrastructure as a service, so virtual machines or a way to spin up effectively compute and storage capacity, through platforms, so that might be things like databases, then all the way up at that point, once you've got your mesh and data taken care of, to the sorts of applications you might compose, or kind of specifically called out microservices, in the sense that you may find you have a bit of most environments you may have a bit of a mixed estate. So for example, you might have something that looks more like a traditional application where it's, say, your payroll system or a product you've bought and installed, and you might have some bespoke stuff that you put in that is more microservice or service oriented, and equally you may have some products you bought that look a bit like that as well. And on top of that, you've got the kind of gateways and things, the means by which people consume this. I think what's really important here is that that model is kind of generic. It doesn't really matter whether you're talking about cloud or on-premise, and that on either side of it, what does matter is that you have some consistent layering of the kind of management stuff, the tooling, and the security that sits alongside it, and that consistency of management is important regardless of whether almost regardless of where you are, and particularly if you're thinking about operating in a world where you're going to have both for a while. You'd want some consistency in that as well. So you don't particularly want to have to run two completely separate security regimes for your environments. Ideally, you want to have consistent automation across the two and consistent management. And part of the reason for that is so you can get the benefits of that automation in all environments. Well, I did say I was going to talk about cloud native. So let's look a bit more at essentially what that application box from the previous diagram would look like, and how that's changing for applications that you're putting, the sorts of applications that people tend to build in the cloud. And on the left, we've got the traditional kind of so-called N-tier architecture diagram. And I'm not going to dwell too much on what each of those layers do, but I do just want to call out a few particular features that I think are really relevant. And for me, what it is that if you imagine that you're a team who's trying to build something new, so I don't know, you want to build a front-end application that allows you to manage contact information for your customers, so sort of customer database. And you decide as a new project that you want to go and do that. In a traditional world, you're going to have a whole series of things you need to call upon to do that. You're going to potentially want some data storage. You might need to go and consume, I don't know, new user subscriptions from some other service. You'll have to build your bit of functionality itself. You might need to make sure that stays up a bit longer, so you want to balance load between multiple instances, or you might do it because there's lots of people you've got using it. And if you look at every one of those layers, you actually don't have much control. So you might be able to build the functionality that goes in the application layer, but those of us who've been a bit around a bit longer and have moved slightly older stuff will be familiar with the world where you build the thing, but then you've still got to give it to another team to go and put it into an application server, for example, so a JBoss or a WebSphere. And the same is true when you want to get some load balancing. A lot of the time that still means, picking up the phone, raising a ticket, getting some folk to put in some infrastructure in a data center for you. And the same again is true at a database perspective. So you might have some dedicated schemas and storage for yourself, but you're probably sharing that on a large scale set of data, sort of clustered data platforms with other people. So again, your kind of ability to control that is quite limited. And when you move towards a more cloud native world, what you're really doing is taking the stuff you want to achieve and breaking it into smaller pieces. And those smaller pieces truly own their remit. In other words, they truly own the data associated with them. It's not part of something where your needs are managed against loads of other people's needs. When you're putting data through to it, you might be going through some gateway that, yes, at a very central level is managed by Amazon, but actually you have a dedicated one for each service. And why this is really important is because it kind of goes back to what Rob was talking about, which is that it's all very well to talk about empowerment and teams doing things on their own, but unless the technology and the infrastructure environment they operate in enables that, it's actually really difficult. And what we're going to do in the next couple of slides is talk a bit more about some of the qualities you look for that that you need of your applications to enable this model. And then we're going to get on to how you can look at your infrastructure to do it as well. So before that, a quick definition on cloud native as well. So, and there's a few themes in here which I think are worth calling out, which we've covered a bit already. So cloud native technologies empower organizations to build and run scalable applications in modern dynamic environments, such as public, private, and hybrid clouds. Containers, service messages, microservices, immutable infrastructure, and declarative APIs exemplify this approach. Now, I think what's really interesting about this is just in the little bits of wording in here. So one of them is you don't have to be in a public cloud like Amazon or Google to be cloud native. And secondly, I think it's almost more importantly, is this list of containers, service meshes, and microservices. These are all things that are quite hyped in the industry. Certainly in working with clients, I've often seen either vendors or businesses looking to sell some implementation say that, because it's a microservice, we will achieve all these other things. And actually, it kind of gets things the wrong way around, I think, which is some of these technologies are ways to achieving an end. They're ways that they are a series of tools you can use to be cloud native, but they themselves don't lead you there. When we're looking at specifically how you sort of judge if something's cloud native, there's actually no point in trying to invent your own on some of these things. We really like, and I think a lot of folk across the industry are now quite familiar with, the so-called 12-factor app pattern, or set of guidelines, depending on how you want to describe it. If you haven't looked at this, I'd hugely recommend it. The link's there at the bottom. You can just Google it. We're not going to go through these exhaustively, but I guess I really want to get home how important these considerations are. And in addition, how important it is, and I guess the importance of thinking how you might be able to achieve these things without having to be in AWS or Google. I just thought I'd pick a few the cloud, and also kind of draw out what's shown in all these lines, which is that there's this kind of many-to-many relationship between the technology and the sorts of effects of application architecture you're looking to achieve. So the ones I thought I'd cover specifically were on dependencies, configuration, build, release, and run. And I guess clearly there's way more detail on the website, but I think it's worth going through. So dependencies, this really is about making sure that when you do something and when you build some software, it has everything it needs to run. And I would contrast that with the world that some of us may have experienced, where you want to make sure that your application runs on a server, and that meant giving a list of prerequisites to someone to install for you. You then drop your application in and kind of hope that it's going to work. And in a world where your dependencies are all packaged together, you know that your application comes with everything it needs to run. And when we sort of then look at the technologies that map, that's where something like containers are really helpful, because you can have a single unit that is deployable with all the libraries that your application needs. When it comes to configuration, this is really about doing something which, to be honest, has always been good practice. So making sure that any of the things that vary between different environments, so say vary between production and test, are external to the application, so you're not having to build specialized versions for each one. Why this gets even more important when we talk about cloud native is because your ability to interfere with stuff while it's running is really reduced. You can't call someone up to apply a hotfix easily if something's running in a container and is only there for a very brief period of time. And lastly, and I think, you know, for me, probably the most important one, is this concept of making sure that the thing you build is known, that you release the known thing, and that you run that thing, and that you have this way of understanding exactly what you've got in production, and you minimize any kind of deviation between that and the original artifacts. And, you know, again, some of these technologies really help with that, but it's absolutely something you can do on premise and can bring a load of benefits, because it helps you understand when something goes wrong, that it isn't something that someone might have changed in a different environment. It helps you reduce the likelihood of new things that you deploy failing and reducing the availability of your systems to customers. So I'm now going to hand over to Rob, who's going to talk a bit about some of the technologies that we can use to achieve some of these effects on premise.
Yeah, so over the next few slides, we want to talk a bit about how you can provide the agility and technology to match the agility and teams that we spoke about earlier. And the first part of that, if the slide will move. Oh yeah, sorry about that. Is modernizing deployment patterns through virtualization, containers, and Kubernetes. So the first role of containers, driven by technologies such as Docker, is to package up the application independently from the infrastructure. You want to include the application binaries and libraries, and importantly, decouple you from the traditional host operating system of virtual or physical machine. So providing you that first layer of separation. And then the second role is really to provide isolation between different applications on the same machine, making as much use of that physical machine resource as possible, but also allowing you better granularity over changes that you may need to make to your applications. The Docker images contain, you know, all of your application dependencies and binaries, and it means that patching those components require the Docker images to be built and tested, deployed into the stack. But that gives you that layer of separation between the traditional, let's say, infrastructure patching approach, where patching the operating system for the guest OS, for example, would require downtime to the application. It provides little flexibility about how you can implement those changes. And obviously, it's possible to do all of this on premise as well. So allowing you to sweat the existing assets using the likes of OpenShift or PKS on commodity hardware without incurring the additional complexity of perhaps running, let's say, native Kubernetes, which can be quite difficult. And then taking that a step further, is looking at serverless and microservice pattern implementation patterns. And so what we want to emphasize on the use of serverless is allowing developers to build microcode functions without having to worry about the underlying infrastructure management. It gives you the ability to produce small code components which can help with that complexity decomposition as well. And it's ideal for situations where code needs to be triggered upon an event and has a relatively small execution time. With the microservice patterns, you can decompose and front run without necessarily the complexity of container orchestration platforms as well. Again, giving you that layer of decomposition can help with separation between applications and giving you that more granular change control. And again, all of this is possible on premise with the likes of OpenFAS or OpenWhisk. And I'm going to hand you back to Marius now to talk about storage abstraction.
we've talked quite a bit about applications and application architectures. And while this talk isn't kind of specifically about data and kind of what your data and analytics landscape looks like in this world, it would be really remiss not to talk about it. And so we're just going to spend a little bit of time covering off how you can, just a few very high level ways that you can, and I guess ways that we see some of our customers looking to modernize data storage without necessarily modernizing their use of data storage with systems that they've already put on premise. And I guess to talk through a few reasons why you might want to do this and where we've seen this sort of approach the most. While I think, for lots of the private sector, and it is kind of understood that, or at least the data security challenges of cloud are better understood, and we often see a greater risk appetite, and particularly where you can quantify benefit in cloud more straightforwardly to revenue gains or costs or potential opportunity. It's still the case that for bits of the private sector, particularly with onerous security requirements like in banking, but also very much in areas of the public sector where it's harder to quantify opportunity gains and it's much easier to quantify security risk. We see quite a lot of folk basically going, well, we know that at some point we might solve some of these security challenges in the cloud. In the meantime, we don't want to keep building stuff in the old way. So how can we achieve very cloud-like storage on premise? And there's a few areas we see that, I guess there's two kind of main ways we see this happening. So one of them is in changing how applications use storage. And I think, what some of us may be familiar with is where we would build some software. We might need to store something like someone's profile picture, for example, and that would get stored on a network share, or it might get stored on shared storage somewhere. But I guess the fundamental thing is that it would be accessed as a file, and the sort of platform that stored it would be one we traditionally associated with file storage. And what we're starting to see now is a move to vendors providing storage, so-called object-based storage, which looks and is behaves like the storage we get in Amazon or in Azure or Google, all the way to the extent that it even can be consumed using the AWS libraries. So it's something that I guess, unless you've had a reason to do it, you may not have come across. But even with Amazon's own library, you can point it at something that isn't Amazon storage. And as long as the storage side of things looks like Amazon S3, the Amazon's library itself will happily talk to it. And that's really powerful for a number of reasons. Firstly, it lets you have applications that are architected as they will be deployed in future. It means that if you have applications that you do want to deploy in two environments, one of which has very secure data, you can build and test it in the cloud against regular S3, and then you can move it on premise and test it against something which is actually where you manage the infrastructure. It encourages the right patterns in terms of avoiding use of file system for applications and instead treating it like an attached resource, which is actually all the way back. If you were being very eagle-eyed, you'd have spotted on the 12-factor page. And in addition, it gives you a load of other quite interesting benefits, not least of which that these modern object storage platforms don't just have to be used by applications to store data, but can actually be used to store data for analytics as well. So if you imagine previously, you might have had to store a load of files in one place and have to buy some disks and storage in the platform for that. And separately, you might have had a large enterprise data warehouse. Actually, if you've got some archival data you want to do analytics on, you have some applications storing pictures or videos, you can actually share all that storage across the two, which means you're going to save yourself some money if you need to do that stuff for a long time. You've future-proofed your applications and made it easier to build them, build and develop them in the cloud potentially before you move them on premise to run in production. By and large, you've got a sort of effectively more on top of that, you've still got that kind of elegance benefit of using object storage. The other side of this is, and I've already talked a little bit about enterprise data warehouses, we're seeing a fairly big shift at a number of our clients now, moving away from relational enterprise data warehouses to data lakes. And I guess to be really clear, we're not specifically saying this has to be big data. This can just be medium-sized or small data. In other words, data where a traditional database or relational database technology is still useful for analysis purposes. So in other words, we're talking stuff at most in the very low terabytes, potentially just in the hundreds of gigabytes, as opposed to the many terabytes, which would be traditional for big data. And there's kind of two things we see happening here. So, and two things actually we would probably recommend that folk with a heavy dependency on kind of the large traditional data warehouse vendors start considering. So one of them is, and really what it's about is making it easier to move to cloud in future, and also really lowering the cost of what you're doing at the minute. And there's two parts to this. So on the moving to cloud front, so that question about portability, when you use technologies like Hadoop, by doing it on premise, you're starting to front run what you need to use effectively the analogs in the cloud. So you might use MapReduce on premise, that's a touch old hat, and the same thing is provided by Amazon. The same is true of something like Spark for your streaming processing. You might be able to use that against an on-premise Hadoop cluster, and then in future you'll require relatively little rewrite to your analytics to move that into AWS and into EMR. Similarly, you might want to set up some smaller kind of data marts where rather than one whacking big data warehouse, you have those in a series of relational databases, and you can look at things like moving off Oracle and moving on to Postgres. In the short term, that might help save you some money in license fees, but then in the long term, you're setting yourself up for a much more straightforward migration into the managed database services on things like RDS. It's also, we've talked a bit about data. There's one last bit, and it's the bit we haven't really talked about much so far. And it's the bit that kind of corresponds to the load balancers and on the N-tier architecture diagram that we saw, and the bit that really corresponds to that really low level, so the infrastructure as a service side of things, when you're kind of just layering up on top of hosting. And I think what I really want to get across here is you don't have to see traditional infrastructure as something that can't be changed, and by that I mean as something where your way of consuming it is kind of absolutely fixed in stone, where it has to be a ticket process, or it has to be sending emails, or where it has to be some kind of service management or agreement. And that actually there's a load of stuff you can do now, even in things which weren't intended to support it, to drive empowerment and to drive delegation of authority to people, while retaining some of the control you get from infrastructure as code type practices. And the ones I just thought I'd dwell on, these are just a few examples, to be honest, and they're things we've seen and done in a number of places. So there's some which are quite simple to enable. So for example, you might have some virtual machines, and you can a lot of if you're on something like VMware or on Hyper-V, they often have APIs to do this, but you can potentially simply allow people to programmatically control those using something like Terraform to poke the APIs that provision stuff. In other words, the same technologies that you might use to poke the APIs on Amazon and spin up some machines there. But on top of that, you can also do some other quite interesting things where you actually try and build a layer around it, or build a layer around something that doesn't support this to support it as well. So for example, if you have a task which traditionally requires a network team to log on to a Cisco console and start either running commands or typing things into a UI, you can absolutely look at using either quite simple technologies like Selenium or Sakuli to drive that and turn that into configuration that then goes and updates your networks automatically, which saves you time for the networking team, but also lets you start to really assure consistency through all your environments. And lastly, on the CI/CD side of things, so that continuous integration, continuous delivery, a lot of all these tools now support basically configuring those deployment pipelines purely as code. And that's something we'd really recommend for two reasons. Firstly, it helps with consistency, but also, again, it means that you can start to template that and abstract it and pattern it so that you have your applications just saying, please build me, and then please deploy me to this environment. And the application doesn't have to understand whether it's going into a test environment or into a production environment, or where that environment is. I'm clearly not going to go through every one of these. And this is really just to, I guess, make a point. So we had a look at the set of tools that folk traditionally use to do automated delivery of software and automated management of infrastructure. And this is a pretty, for any of you who've worked with these, this is a fairly familiar smattering. And it's the case for pretty much all of these, some of which assume quite a high degree of maturity in your engineers and your organization, particularly that box out to the top right, that aside from the cloud compatibility bit, these things all work really, really well with on-premise. And that's something that we've seen be really powerful for one client where they'd gone from having an engineering team manually running commands on boxes and deploying a product which was delivered to them via a CD. Something as simple as copying the contents of that CD into an artifact repository, so that's Nexus in this case, and wrapping this process using a mixture of Jenkins and Ansible, got deployment times for these platforms down from about 5 months to about 5 weeks. So still, not as quick as if all the technology in the application itself was totally greenfield and done architected the right way from scratch. But for something where the software was still delivered by CD was pretty great. So I'm now going to hand back to Rob to talk after all the tools and kind of really wrap this up for us.
Yeah, so for us, what's all this all about? It's about front running the ways of working and the architecture and technology that gets you ready for cloud adoption or operating in a cloud-like environment in your on-premise data centers. And the people, process, and technology is inseparable. It's really hard to have empowered ways of working without the technologies that enable programmatic and delegated control. From the people angle, you need to ensure that you can safely empower people to operate in a self-organizing manner. And your process needs to be streamlined to be lean and centered around those people. And the right level of governance to deliver value as fast as possible, but as securely as possible. And it's not safe to empower development without the control and traceability and repeatability that CI/CD gives you. In order to minimize that bumpiness when it comes time to move, you want application systems to be as portable as possible and make sure that it's a good fit for the cloud environment they're going to be deployed into. And as we've seen from those tools and technology, these things that you can do while continuing to sweat the existing investments that you've got in your on-premise infrastructure. And also, not everything will be able to go to cloud. So the investment that you make here will be able to also be reused for those things that can't go to cloud, and it will really benefit from these changes in terms of the consistency and speed that you can operate in your on-premise environments. And
so I think, for us, if we go all the way back to the beginning and some of those slides we saw, we talked a bit about modernization and migration and how they're not necessarily the same thing. We've talked a bit about the different ways that you can front run this and why this is important for getting time to market benefits. Rob's just talked about how it helps you sweat your assets as well. And I think for us, there's this there's a load of puzzle pieces on the floor here or on the screen. And I think really it's about how it feels to do that migration and just really emphasizing that you don't have to wait and that you can get started now, that you can reap those benefits already, and that when you do migrate, so when the other things fall into place that let you do it, whether it's a security thing, whether it's a procurement thing, whether it's a financial thing, it'll all feel an awful lot easier. So thank you very much for listening to the presentation part of the webinar today.
If you still have questions or want to follow up on some of those topics, the emails are on there. Thank you, Marius and Rob.
Thank you. And thank you. It's an absolute pleasure to talk to everyone today.